So far, we've been talking about kinematics, which was simply the description of motion. Now we're going to talk about forces, which is the beginning of dynamics, which studies the causes of the motion. But first, let's do a little bit of review. We remember that we described an object's position with a position vector from an origin, and then we would talk about its displacement, which was the change in position, delta x for change. I'm leaving off the vectors right now because we've dealt so far only in one dimension. We talked about the velocity, the average velocity was the rate of change of position with time, or delta x over delta t, and the instantaneous velocity, we simply took the limit as delta t became small so that this became a derivative. We also learned that if I took a graph of position versus time, average velocity was the slope of a line connecting two different points, the line connecting the 2 points between which we wanted to know the average velocity, and instantaneous velocity was the slope of a line that was tangent at one single point. Then we went on to study acceleration, and we found that acceleration was to velocity much as velocity was to position. That is, it was how quickly velocity was changing. So the average acceleration was delta v over delta t, and the instantaneous acceleration, we simply changed that for a derivative. And if I were to plot velocity versus time, acceleration was the slope of a line between 2 points for average acceleration, and instantaneous acceleration was the slope of the line tangent at 1 point. We also learned some useful equations in the event that we were dealing with constant acceleration. The two main equations that we deal with are that the velocity at time t is equal to the velocity at time 0 plus the acceleration times the time, and that the position at time t is equal to the position at time 0 plus the velocity at time 0 times the time elapsed plus 1/2 the acceleration times time squared, where the 1/2 came either from geometry, looking at a triangle, or from integrating time. A couple other equations which may be useful and can all be derived from these ones are that delta x is equal to 1/2 v final plus v initial times time, or that v squared equals v initial squared plus 2a delta x. This one you can solve find by solving the top equation for acceleration and using it to eliminate acceleration in this equation. This one you can find by solving the top equation for time and using it to eliminate time in this equation. There's a number of other variants, and sometimes it's easier just to go back to the definitions. So that's our review of kinematics.